Today we're going to discuss two topics. We're going to talk about how to combine like terms, and then we're also going to talk about the distributive property. But first, before we get started on both of those, we need to look at some vocabulary, so make sure that you're writing this down. We've got 4 here. The first one we're going to discuss is the vocabulary term. Term is either a number, a variable, or both together. So you may have seen something like this, 2x, which is considered a term. This is a number and a variable. It could just be y, or it could just be the number 3. So all 3 of these are representatives of a term. Now, within a term, we can get more specific, which leads me to my next vocabulary word, which is constant. Constant is the number with no variable at all. So a constant would just be a number. It's really like this one right here, just the number 3, but I'll give you another. An example of a constant is the number 5. An example of a constant is -11. An example is 0. So a constant is referring to just a number. All right, let's get a little bit more detailed. We have the vocabulary term, which is coefficient. Coefficient is the number directly in front of the variable. Okay, so let's say I have the term 5y. The coefficient would be 5. Or let's say I had the term 10xy. The coefficient in this term is 10. So coefficient is the number directly in front of the variable or variables listed, because there could be more than one. All right, so what happens if you have terms that look the same? We've got a vocabulary term that is called like terms. Like terms. They have the same variables and they're raised to exactly the same exponent. So let me give you an example of 2 like terms. 2a and 4a. These would be considered like terms. Why? They have the same letter and they're raised to exactly the same exponent, which is an understood 1 up here. Or you have something like this, 3x squared y, and another like term could be -100x squared y. Now, why are these considered the same, or why are they considered like terms? Notice nowhere in the definition did it talk about that the coefficients had to be the same. It said that the variables had to be the same and they had to have the same exact exponent. So check this out. We have x raised to the second here, and we have x raised to the second. That matches. We also have a y in each of these terms. So these are considered like terms. They have the same variables, x and a y, and they're both raised to the same exponent. Let me show you one that is not a like term. So not. 3a squared and 4a. These are not like terms. Now, granted, they have the same variable. There's an a here and there's an a here, but they do not have the same exponent. This is a squared. This is a to the first power. So these are not like terms. It just is what it is. So let's talk about what do you do if you have like terms. What's the next step? And we're going to combine them. Let's look at a couple examples. Okay, so this is not like terms. We discussed this. This first example here, I have -13x squared plus 3x squared. Now, my question to you is, are they like terms? I hope you said yes, because I'm noticing they both have an x squared in each term. There's both an x squared. So these are like terms. So how do you combine them? all we're going to do is we are going to add or subtract the coefficients. So we have a negative 13 and a positive 3. So let's add these together. Negative 13 plus 3, and I've got negative 10. But what made them the same? What made them a like term was the fact that both of them had an x squared. So I'm going to keep that coming along. So we've simplified these two like terms and combined them, and this is what we get. So remember, like terms, same variable, same exponents. Let's go here to the second example. I've got 2d plus d. Are they considered like terms? Yes. Both the letters are the same. I have a d to the first power here and a d to the first power here. Now, what are the coefficients? I see a 2 and then I don't see anything. Now, don't mistake this for 0, because if it was truly a 0, then there wouldn't even be a letter here. There would be nothing. So there is an understood 1 that's right in front of that letter. So watch for the understood ones. So here we go. Now I take the two coefficients and I add them together. 2 plus 1, which is 3. And what made them alike was the fact that they had a D. Done. Now it can get elaborate. Notice this third example here. 12a squared bc minus 10de minus 2a squared bc plus de. Now we are not going to combine all the coefficients here. Why? We only combine coefficients of like terms. So I need you to pick out which ones are like terms. I hope that you grouped this one together with this one here. Let's take care of this yellow right now. So I have 12a squared bc and I have a negative 2a squared bc. So these are the same because they had exactly the same letters and each letter was raised to exactly the same exponent that matched either one. So I'm going to take the two coefficients, which is 12 and negative 2, and I'm going to add them together. So 12 plus negative 2 is 10. What made them the same? The a squared bc. Okay, let's pick the other two. They are alike. I have a negative 10 de, and I have a plus, what's in front of that d? You got it. It's a 1. So I have a 1 de. Let's combine both of those. Negative 10 plus 1. Negative 10 plus 1 is negative 9. What made them the same? The DE. Now I can't combine these together. This is not a 10 and a negative 9. They cannot go together because they do not share the same variables. This would be my final answer. It's as far as it can go. Now before we are done, let's talk about the distributive property. Okay, the distributive property is used to multiply one term to a lot of stuff. And what indicates distributive property is parentheses. And we've talked about parentheses implying multiplication already. So let's take the first example. 3 times all of this inside of here. And there's two terms inside of here. We have 4m, and we also have a negative 7. Notice I didn't say a positive 7 with a subtraction sign. Go ahead and get used to taking the sign in front of that specific number. It'll help you as far as staying organized in your work. So we are going to distribute, meaning we're going to multiply this term on the outside, and we're going to distribute it to everything inside, and we're going to distribute it twice because there's two terms in there. So let's take it one at a time. 3 times 4n. Now we don't do anything with the letter. It's here right now, but we are going to multiply the coefficients. 3 times 4 is 12. So our first term is 12m. Let's do it again. 3 times the negative 7. And 3 times negative 7 is a negative 21. Now after you distribute, look to see if you can combine like terms. Can we combine 12m and negative 21? No, we can't because they do not share the same variable. This is a constant, so they cannot be combined. All right, let's go to example 2. So we have a negative, open parentheses, 5g minus 6. Now, what are we distributing? It looks like this negative sign. But what number, this will help you, what number is understood in front? You're right, it's a negative 1. So really, we're taking the negative 1 and multiplying it to the 5g. And we're taking the negative 1 and we're multiplying it to the negative 6. So let's do that. Negative 1 times 5g, multiply the numbers, which is negative 5g. Negative 1 times negative 6 is a positive 6. Watch for that right there because two negatives multiplied together equals a positive. So this is a positive 6. Now, it also standing for a plus sign or addition. You can look at it that way. But think about the signs in front of the numbers as positive or negative. That's going to help you. Now, sometimes the distributive property can come from the back. And usually indicating a distributive property from the back, they're going to use parentheses around it. So that's okay. We'll just draw our arrows from this side. 6 goes to the 3n. 6 times 3n is 18n. And then 6 times negative 7 is negative 42. So reading this for someone to write down, you would say 18n minus 42. When working the distributive property, use those signs as positive and negatives. All right, one more extra thing. We talked about writing algebraic expressions earlier in a previous video, so I wanted to show you what would be a code word that would imply that the distributive property is actually happening, and it is the word of quantity. So notice this. We're going to take this and we're going to write it in an algebraic expression. So twice the quantity of b plus 9. Now this is something that we've had before, the b plus 9, and I think you guys would agree if I do this right here. Now twice, we know that that was multiplying with the number 2, okay? Multiplying with the number 2. We've seen that before. So we are going to be using the number 2, but how are we going to use it? Wherever the word quantity is, normally that's where you're going to put the parenthesis. So check this out. Twice the quantity. To the quantity of b plus 9. Let's close that off. So this is what it's saying. 2 times whatever b plus 9 is. Not 2 times the b, it's 2 times this together. And instead of saying this together, they use the word quantity. So just know that quantity represents, is a code word to use parentheses. And this would be our answer of writing it as an algebraic expression. Now we could, watch this, we could actually simplify this out. We could do the distributive property. So say we took 2b plus 9 and actually do the distributive property, and I want to see what you get. Pause the video, work it, and then press play when you're ready to go. All right, I hope that you got 2b plus 18. If you did, you are good to go because that's right. 2 times b is 2b. There's an understood 1 right here. So it's like 2 times 1 is just 2. And then 2 times a positive 9, which is a positive 18. So this is going to wrap up our lesson on combining like terms, distributive property, and I've tossed in writing an algebraic expression. So we'll work with more intense problems, maybe toss some fractions in there, and we'll take care of it. All right, see you in class.